Thank you, Pavel, for the introduction. Thank you for inviting me. Yeah, my part here today in this community meeting is presenting you the Potter project. The subtitle would be Kubernetes Workload Lifecycle Management Made Easy. Now on the right-hand side, you see our fancy logo, and in the upper right corner, you see the usual Gartner logo. So there is some similarities, and this is yeah, because we are now part of the whole Gartner family with the Potter project. Now, first of all, you might ask why Potter. Will Joanne K. Rowling join the meeting? No, she will not, unfortunately. I tried to contact her, but no, she doesn't have time. No, just kidding. No, actually, to be part of the Gartner family, you need to have, and that's kind of a mandatory requirement, some kind of botanic references. And we thought Potter might be a good fit because in the end, we are like planting stuff into Gartner managed clusters. And this is why we came up with the name Potter. Yeah, I'm Ingo, product owner at SAP. Yeah, since already a few years, started my SAP journey in 2002. So yeah, that's roughly the background of myself, very briefly, and the background of the Potter project. The agenda of my talk is rather brief. Some motivation. Yeah, why do we need another Kubernetes deployment management tool? I will talk briefly about the architecture, very briefly. I stripped it down to make it more or less easily consumable for people who have never worked with the Potter. And then main focus will be the demo later on. Take it as it's more like speed dating the Potter project. Yeah, so we will not go into all of those details, but it's just rolling out the Potter, what it is and what it tries to solve. All right, motivation. Yeah, why do we actually need another deployment tooling? Yeah, what we thought is there are already multitudes of deployment tools, and yeah, some of them are already around for quite some time. Some are still new kits on the block, and also the Potter will be another new kit. So if there are already a lot of those tools, why do we now need another one? Yeah. So we even make the jungle of tools out there more complicated. Yeah, when we started to think about how we could add some icing on the cake to what the Gartner already provides, we did some evaluation already several months ago of the various existing tools. And what we found out is, yeah, it's always a bit of a hassle to set up all of this, all of these tools. You have to manage those tools. Some tools need to run some kind of agent or controllers within the cluster that they are supposed to manage the deployments in. And what we wanted to have is a very easy way of doing Kubernetes deployment management in a declarative way. We wanted to have not the necessity to have an agent or controller run in the target clusters. And we wanted to provide a central catalog where you can see deployments that you want to make available for your developers or ops people to deploy into clusters. So that is the very rough problem statement where we were coming from. And we found out we didn't see a tool out there back several months ago, which fulfills at least those three priorities. And we had some others in mind, which I haven't listed here. And also for them, we didn't really find the best fit that we want to promote to the community and use ourselves, of course. Based on those findings, we started the Potter project. And here's some bullet points, what we had as goals for the Potter project, which it should have. So first of all, it should be a centrally managed service and not something that you have to deploy in all of your cluster. We wanted to make it a bit open. So first of all, yeah, of course, we wanted to manage Helm deployments, but we wanted to have a rough architecture that can be more or less easily enhanced to also support other Kubernetes deployment types. As I said, we don't want any controller or agent running in the cluster. Side note, if the cluster is fenced, of course, you need something that calls from within the fenced environment This is a different thing, but if we're talking about standard clusters within your landscape, then we don't want to pollute the cluster with additional agents or controllers. We wanted to have a central UI. If you're more into manual deployments, you can do that because we offer a UI for even easier deployments. We are introducing a rather simple custom resource, and this baby we call cluster bill of materials, which exactly shows what this thing is about. It is more or less just a list of deployments that you want to have in your cluster and be reconciled at any point in time in a declarative way, of course. And what we also wanted to see is get this tool somehow integrated into a Gardener deployment, so that whenever you get the Gardener, you would get the Potter project out of the box. That might come soon. We are still in discussions here internally on how to do that, but you might expect this in a few, I don't even know the timeline, weeks or months. All right, so yeah, we started the Potter project. Just a rough outline on how this is, how we did this in Git. So we have mainly two repos, both of them located under the Gardener organization. So this is where you should look them up if you're interested. The main two Git repos would be the Potter Hub, which is in the end the UI part. This is heavily based on the fork of K8s. I guess most of you guys know the K8s application. But what we found all the K8s, at least several months back, you need to have K8s running in your cluster which you want to manage. And this has been changed to the core of K8s by us using the fork, so that you have a Potter instance running centrally, which will then be able to do deployments in all of your shoot clusters that you're managing with the Gardener. Then we have another Git repo, which is the Potter controller. And there we have several controllers that actually perform the deployments and reconciliations, like, for example, a dedicated Helm controller. And this is where the extension comes in. So we could have some other controllers dealing with other technical Kubernetes deployments. That's roughly it. I know, I looked it up some days ago, again on K8s. They have now also integrated multi-cluster deployment, which is right. And I think this just shows that our initial direction of changing K8s to a more central service is exactly right. And people were actually asking for that in the K8s community. Now it's a bit of a bummer that they now also have this remote cluster support, and we did it also in K8s. But we have it tightly integrated with the Gardener, and I think that's a big plus for the Potter project. All right, a rough architecture outline, as I promised. You know, there is a garden cluster. This has some service account handling for project members, for example. We added some CRDs into the garden cluster, most prominently the cluster bomb CRD, which is the definition of how this list of deployments will look like. And this is what we have roughly in the garden cluster with respect to how the Potter works. Then we have this little snowman here. And yeah, it's just a snowman because my drawing skills are rather limited. Let's call this guy project member. And this project member is supposed to do some deployments in the target cluster. How would he do that? Ideally, he would just define a cluster bomb. So specifying the list in a declarative way of the deployments that he wants to have in the cluster, applies that to the garden cluster using the service account in the respective namespace within the garden cluster of his Gardener project. So there you would have the cluster bomb, and you will see later on what you pass to the cluster bomb is the kubeconfig of the cluster that you want to actually deploy to. Then, of course, this will not happen without something that runs with regards to the hub itself. So we have internally, we call this hub cluster. There is a controller that runs in this cluster, and this controller has access to this project namespace, so it can access the cluster bomb and therefore also the kube config, and then applies this to the target cluster. That's in a nutshell, without going into more details here, how this works together with the Gardener cluster. Sounds easy, and it is easy, but if I were you, I would not really believe in PowerPoint presentations. I can talk a lot, but let's see how this really works within an end-to-end demo. So I need to exit this, and while I'm doing that, people usually pray to demo gods these days. I don't do that because I don't think that demo gods will help me. Have I lost the sharing actually? Oh, no, it's still sharing, right?
Sharing works.
Okay, perfect. Yeah, I'm not praying to any demo gods because I think it's more or less 80% preparation and 20% luck, whether it works. I did my 80% part, so now let's see whether I have a bit of luck so that we get to the 100% and the demo should be working. What I will show you here is on our Gardener landscape, we have a project called Hub Test. There I have a demo cluster, which I would just open right here. You should be familiar with this, I guess. And if you scroll a bit down, you see a new entry here saying this is the internal name of the Potter project is Kubernetes Applications and Services Hub. And then you can just click on this. And then you see the UI part of what we offer with the Potter project. If you have used K8s, you should see some similarities here. So this is exactly in the end how K8s looks, a bit of styling done and some changes here and there, but mainly this is a K8s UI. We have different sections here on top. So first of all, you see applications. Looking at all namespaces here, you see there aren't any deployments here in this Kubernetes cluster. Then we have a tab, and this has been introduced by us, which is called cluster bombs. And yeah, as of now, there are still no cluster bombs in this cluster. And we have a catalog. This is also heavily based on K8s. We changed some controls, made it a bit easier to be used, but in the end, it's a list of all the available Helm charts that are exposed in the repositories that we have connected to this installation, which is totally configurable. So you can add whatever Helm chart repos you want to have via a simple configuration. We exposed the Bitnami one, and then we have two internal ones here just to show that, yeah, it's possible to have your own Helm chart repositories right here if you want to only expose like curated Helm charts where you know they're going to be working in your environment. You can only expose those Helm chart repositories. That's the UI, and you can use the UI to have simple deployment, like whatever is used usually in those demos is the Nginx controller. Let's do that. Hit deploy. Let me use the Nginx namespace here. You can, of course, create new namespaces right here in this drop-down menu. Now I have selected the namespace. I will just go ahead using the default values. It takes some seconds, and then you're going to see here it deploys the Nginx controller. It's not yet ready. Takes a bit, still in pending mode. Yeah, some details here about the actual deployments, and you already see here on the left-hand side where I have K8s open with, in the context of this cluster that you see here in the UI, and you see the Nginx deployments coming up. That's easy. If you want to go the manual way, you can do it like this. Now it seems everything is ready. The 2 pods are up. You can see that here. And that's it. So easy way to just do manual deployments in a cluster using the Potter UI. But let's get rid of this here. What I actually wanted to focus on is how we introduce the cluster bombs. What are they made of? What kind of data do you need to provide to cluster bombs in order to do the deployments in a more declarative way? For that, let me bring up VS Code. and I have here a cluster bomb, and that's already it. So not a lot to do here. We have the usual metadata stuff here on top. We should give it a name. You have to reference the namespace of the project in the garden cluster. You can read out the description here on the right-hand side if you want to. And one of the main things you need to do is pass in the kubeconfig of that cluster. And in my case, it's the demo cluster.kubeconfig. This is how our controller is able to then deploy into that cluster. And then the most prominent part here in this list of deployments always starts with this application config section, where you define if you want to never-ending list of deployments to be deployed in your cluster. You give that thing an ID. You say, what kind of deployments do you want to actually deploy here? In this scenario, in this example, I will do a Helm deployment. Let's give that thing a name, tell him where it should be deployed into and into which namespace, and then tell our controllers where it should actually be retrieving the Helm chart from. In this case, we do a catalog access. So we say the repository is the Bitnami one, the chart name should be Nginx, and then the chart version is specified here. So let's just try that. Clear this crap from the screen. And all you got to do is K for kubectl minus F. Like this, just hit return. It gets applied. Our controller will see this thing and do whatever is necessary to deploy the Nginx right here in that namespace. You can also observe this in our UI, of course, if I would be able to bring it up again. Here we go. Quick refresh on that one. And then you see Nginx is deployed. I'm not using the latest version here. This is why it says update will be available. You can click on this tile and see, yeah, the deployment has been still pending, but it's running, and now it's running. And also from this tile here, you can navigate to the bomb itself, because the difference to what I just showed you before, we have now used the cluster bomb in order to do that deployment. And there we have a rather sophisticated, I would say, status section, which might be the most interesting part here for you guys to look at. Because this enables you to do some checks, even some automations based on the actual deployment state of what you have just deployed to the cluster. So we have a detailed state for each of those deployments. In this case, we only have one application, and all of those applications have been deployed. So it's 100% progress. Everything works. Everything is running. You see the last operation that happened. You see the reachability of the cluster. We also included that, and also the readiness of the deployment. We also have a sophisticated, I would say, condition section here where you can really program on those conditions of this CR. In the end, the condition here says all applications are ready, and that's true, and the cluster is reachable. You also have calculated number of the overall deployments that are specified in this cluster bomb, and the overall number of the ready deployments is also 1. So this is why we say 100% of everything that you specified in this cluster bomb has been deployed successfully. Okay. As a side note, right now, the cluster bomb integration into this UI is on a read-only basis. So you are, as of now, not able to create cluster bombs here in the UI. You're not able to edit them, and you're also not able to delete them. So it's more like checking the state of the existing cluster bombs that have been applied to the cluster via some scripts or whatever you use to do the kubectl stuff. If I would go ahead and say, delete this cluster bomb, of course, nothing too fancy. It will just clean up all the deployments that I mentioned in this cluster bomb. If you go back to the UI, after refreshing it, the cluster bomb is gone, and also the application is gone. So that was easy. It was just one deployment. Why should I go the cluster bomb way if I only have one deployment, you might ask, and this is totally true. So this is why I've added 2 more deployments right here. Let me just uncomment them. So what we should now see is getting the Nginx controller, console, and Prometheus being deployed into the cluster after I do another kubectl apply of this file. It creates the cluster bomb again. It brings up the Nginx. It brings up console. This usually takes a while. Trust me, in some minutes, console will come up. But wait a minute. Didn't I specify 3 deployments and now only 2 are coming up? Let us check in the UI whether something is wrong here with this cluster bomb. You see it's still pending. Overall, we have 3 applications, progress 33%. One is okay. Let us check in a minute what is the one. You can already guess it might be the Nginx, which has been deployed already. For one, we don't actually know the state, and one is totally failed. So now you have seen it was switching. Now 2 are okay, and 1 is still failed. Let's look into the status section whether this works or not. You see here, installation was successful for the Nginx controller. It's ready. Everything's great. Coming down here to console, also this deployment worked. Everything's great. But here we have a problem. We see Prometheus is not available in the version 4.1.2253, which actually I did on purpose just to show you that we also have some possibilities here in the status section to find out why certain deployments didn't really work. So this failed, and also in the overall section down below, we see some applications are still pending, and the one that is pending is Prometheus. We have an overall deployment state of 66% because we mentioned 3 and only 2 are actually deployed as of now. So let's just fix that. So let me just put in here the right version. If I remember correctly, it should be 4.1.2. Hit save, apply the same thing. And now out of a sudden, hopefully, Prometheus comes up. So now our controllers are able to find the actual Helm chart with that specified version and do the deployment. It will not touch the Nginx, it will not touch the console because those things are already running in the specified version, so no need to change anything here. But the Prometheus is now specified in the right version and deployment can proceed. You will see that here in a minute also in the UI. So it's overall, it's still pending because it's still performing the Prometheus deployment. In a second, this should change to 3R, okay, and then we get a 100% deployment state here. And also in the conditions down here, you should see that everything runs in a second as soon as all of those Prometheus pods are up and running. Should happen in a minute. What you can also do, you must not always use the UI in order to get to know the conditions. You can also do a describe on the cluster bomb itself, because the UI actually just displays whatever the describe command would return. So also programmatically, you can make use of all those conditions and the deployments which are running, or even have a look at the events that took place during the after the initial apply of this cluster bomb. So here we have like a eventing list of all the things that happened. Okay, I want to get rid of this again, and that's like as easy as doing just a delete, and everything gets deleted, the cluster bomb, as well as all the applications. Anything else I wanted to show? I think that's it. So this will be cleaned up in a second. Let me switch to the PowerPoint just for one last slide. So we did the demo. It was good. Yeah, join our community. And this is I borrowed this, of course, from the Gartner PowerPoint. So as I said before, we are located under the Gartner organization on github.com. If you want to get in contact with us, just create an issue there. Or if you want to get in contact direct with me, just drop me an email. I'll be happy to help. As of now, located in the home office, as most of us. Yeah, and I think together with the cluster bombs used in a context of the Gardener, you get even the Kubernetes workload deployment management on top of the cluster management that the Gardener provides. Yeah, that's it. Thank you all for listening. Thanks for your time.